All right, so looking for outliers in two random variables. So there are other circumstances to have outliers. Okay, this is just one of them, and this is the only one we're going to touch on here. So what does a lower outlier boundary and an upper outlier boundary look like in a scatter plot and a line of regression? So the lower outlier boundary and the upper outlier boundary are lines parallel to the line of regression and offset from the line of regression by 2 times the residual standard deviation. All right, so what I've got here is I've got a picture. So we've seen this picture a number of times. You know, this is third exam score versus final score. We've got our scatter plot, and we have our line of regression here. Now, what you'll notice is, there's an upper outlier boundary and a lower outlier boundary. And notice those two boundaries are parallel to the line of regression here. They're parallel, and their distance from the line of regression is 2 times the standard deviation of the error. So if you take the line of regression, and you add 2 times the standard deviation of the error, then you'll get the equation of this line. If you take the line of regression and you subtract 2 times the standard error, then you'll get the equation for the lower outlier boundary. And with these two boundaries in place, any data point that's below the lower outlier boundary or above the upper outlier boundary would be considered an outlier. And you can see this point right here, that is an identified outlier because it's outside that upper outlier boundary of 2 times the standard deviation of the error. Now, this standard deviation of the error is what I told you in the preceding video how to get in both the NumWorks and the Texas Instruments calculator. So, how do you get these equations, for the upper outlier boundary and the lower outlier boundary? Now, what I'm doing here is I'm doing this visually, right? So you can kind of see mapped out in 2 dimensions what we're doing. Okay. Now, once you maybe understand visually what you're doing, then when we do it again, but just using numbers, I think maybe just the numbers will make sense because you would have had the context of this picture. Okay, so what you do is you start with your line of regression, which is this equation. And then you have your 2 times the standard deviation of the residuals. Okay, the standard deviation of the residual was 16.41, and you're doing 2 times that, which gives you 32.8. So in order to get your upper outlier boundary, you're going to take your line of regression and you're going to add 2 times the standard deviation of the residuals. Then to get your lower outlier boundary, you're going to take your line of regression, and then you're going to subtract 2 times the standard deviation of the residuals. And what you'll notice is that your line of regression, your upper outlier boundary, and your lower outlier boundary, they all have the same slope. That's what makes them parallel. They both have the same rise and run. That's what makes them parallel. But what offsets them, what makes one higher or lower than the line of regression, is based off of the value of the y-intercept. So you'll notice here that the y-intercept is actually getting larger. Okay, the y-intercept is going up, which is making an equation of a line parallel and up. Down here, we're taking the y-intercept and we're subtracting from it, which is going to make it drop down. The y-intercept will go down, and that'll give us the equation of the lower outlier boundary, which is down, which is below the line of regression. All right, so you can see here on the Texas Instruments calculator, I've got the scatter plot, I've got the line of regression put in. The line of regression is this first equation here under y1. Okay, then I took this line of regression, I copied it down here under y2 in order to graph that. And you can see I did 173.51 plus 2 times 16.41. So the fact that I did a plus here means that this y2 is going to be the upper outlier boundary. And what I did is I selected this little slash mark. And if you select the slash mark and hit enter, you can change it so that it'll shade. So I had it shade the area above this upper outlier boundary. And then this equation for y3, this is our lower outlier boundary. And in the lower outlier boundary, you can see here we have the slope x minus, and here's our y-intercept, which is 173.51 minus 2 times 16.4. So 173.51 minus 2 times 16.4. And that gives us the lower outlier boundary. And I made the calculator so it would shade the region down below. So all the data points that are between the upper outlier boundary and the lower outlier boundary, these are all not outliers. But you can see this point right here, it's just in that region. That's the point 65, 175. That point 65, 175 is an outlier because it's in this outer region. It's above the upper outlier boundary. Okay, so here I put data point 65, 175 is above the upper outlier boundary. So, I'm first trying to show this visually because I think we can think about, the borders between two countries like North America and Mexico, for example. And if you had a skydiver flying in a plane right over the US-Mexico border and he jumped out, if he lands, in the United States, versus Mexico, he's landing on one side or the other of the boundary between the two countries, right? And so here we've got like the boundary between two countries. And if the data point lands here, it's considered an outlier. If the data point is in here, it's not an outlier. Okay, so it is a lot to kind of graph this stuff out. Okay, but if you have this image in mind, there's a simpler way to do it. And it's simple. I think it's simpler if you keep that previous image in mind. So the simpler method is to look for residuals that are greater than 2 times the standard deviation of the residuals or lower than minus 2 times the standard deviation of the residuals. So if you think back to the NumWorks residual plot, okay, we saw this earlier. The NumWorks residual plot gives you the residual standard deviation at the bottom of the screen. So you see down here at the bottom of the screen, it gives you the residual standard deviation. So now if you do 2 times that, right, 2 times 16.41 will be 32.82. And so if you go on this graph, so here's 0, here's 20, there's 40, 32.82 is somewhere right about here. right? This would be 32.82. And if we go in the opposite direction, here we've got negative 20. I mean, negative 32.82 would be off the graph. Okay, it'd be somewhere right about here going that way. So that'd be negative 32.82. And so what you want to do is you want to look for any data points that are either above 2 times the residual standard deviation or below 2 times the standard deviation of the residual standard deviation. And just like what we just did with the Texas Instruments calculator, you can see that this point right here is clearly above 32.82. But in the NumWorks calculator, it just gives you the value of the residual for that data point. So the residual of that data point was 34.7. 34.73, and you can see 34.73 is greater than 32.82, which means that point is an outlier. All of these ones here are not. These ones are okay. And there's no data points that are out here below this lower outlier boundary. So if you can, kind of read that you've got to double this number and use double that number and check to see if these values are either greater than double that number or less than double that number. That's what you need to do to look for outliers. The other data point, which was this one, you can see down here, it has a residual of negative 19. Well, negative 19, is still in the okay region because negative 32.82 would be somewhere down here. So this is inside the lower outlier boundary, not outside it like that. So that one's okay. If we do this using the Texas Instruments calculator, remember we did that residual function to get us all the residuals. Come back. Let me click on stat edit. So here we did that residual function. Let me go back. Let me do that again. Why not? So here, if I program list 3, let me clear it. And I go into the list function here. So I want to hit second, stat, and you see this says residual. Click that and hit enter. It gives us all of our residuals. So you would have to have written down what the standard deviation of the residuals was. Multiply that by 2, which is 32.82. And see, this number is above. It's greater than 32.82, so that's an outlier. And none of these negative numbers are greater in the negative sense than negative 32.82. So this point here with this residual is an outlier, and that's the point 65,175. Okay. So next, let's see the degree to which the single identified outlier affects the line of regression. So here's the old data set that we started with. This point we identified as an outlier. And now we're going to delete it. And now we've got a new data set without that outlier. Notice there's one less. And if we go through and we take that one out and we do a line of regression on this new data set, let's look at the differences. So before is when we had the outlier in, after is when we had the outlier out. And so you can see the line of regression with the outlier is different from the line of the regression without it. So you actually get like a steeper slope, right? You get a slope that's 7.38 versus 4.82. And you can kind of see that reflected here in this image. Um, this slope of this line of regression, okay, it's going up and to the right, but this one's going up and to the right more steeply. It's going upwards faster, okay? And that's because it's got a higher slope. The X bar, Y bar value, okay, that changed. But the biggest difference here is in the correlation coefficient. Look at the difference there. Remember, the highest the correlation coefficient can go would be like +1 or -1. Look how close the correlation coefficient is now to 1. Since that outlier, which is right here, since that outlier was removed, we got a better fit compared to when it was there, right? So just by eliminating that one point, we now have a better fit to these points versus trying to include that one and there being more variation here. That's why it's important to look for outliers and remove them. And it's not a crime to remove them as long as you have a procedure, a mathematically valid way or reason to find them and to remove them, and you're transparent about why you removed data points. Then you're okay. And previously, because you use lines of regression to do predictions. So if we included the outlier and we put 68 in for X, we get 155 out for Y. But look at what happens when we take the outlier out. If we put 68 in, we get a final score of 147 out, right? That's different. We get a different prediction. If we put 73 in for a third exam score before the outlier was taken out, we get 179 for a final score. If we put in 73 into the line of regression after the outlier is removed, we get a final score that's higher of 184. So taking out an outlier altered our predictions, and maybe our predictions are better for it. So please note that only one outlier significantly changed the linear regression and correlation analysis. Now you're already learning to do a lot with linear regression and correlation. So I didn't put this, at least maybe I've changed things now, but originally I put this at the very end of chapter 12 because you're already learning a lot. But typically you would do this outlier detection first at the very beginning because it affects everything else that follows later. Okay. But I thought that for right now, you guys being introduction to statistics students, that it would be best to maybe save this until the end. It'd be better to learn how to understand and reason those 4 questions without adding an extra step to it all. Okay. Plus, I think with you having some experience now, doing all the other sections first, it gives you a better handle on linear regression and correlation to where maybe this part of it will make better sense to you now. So that was a judgment call on my part. I hope I'm right. But please let me know if you have any questions.